Hello everyone, welcome to our third video on Arduino. So I hope you all are doing fine. And today we're going to be doing a lot of programming, not what is that hardware, or we're not going to be connecting any wires. So yeah, so last few videos have been mostly theory, so I thought we'll do a bit of programming today. And what are we going to be seeing today? We're going to be seeing the types of data in Arduino, or the types, the ways that you can store data. Okay, so let's get started. So now let's start a program, and we are going to be learning about the types of data as I already told. Now let's see the first type of data that can be stored. We have to store numbers. So there are two ways you can store numbers. The first one is the int. Now the int variable is a type of data which can store numbers, but it has a limitation. Now this limitation is that it can only store values between minus 32,768 and 32,767. See the value of the screen. If you didn't understand what I said, that was a pretty big number actually, so it's fine if you didn't understand. So this is the limitation. You may ask, that's huge, we won't be needing bigger numbers. But then here comes the problem. The thing is that you might need bigger numbers in programming, so I'll come to that in a moment. But before that, I wanted to say that because we're using an Arduino Uno, it's 32,000, that's the limit. But then if you're using any other boards like the Arduino Duo, you might have a bigger int, which is like you might have a int which stretches from 2 billion and all those stuff. So don't need to worry. Okay, this is fine for now. But then if you want bigger numbers in programming, we have the next one, which is known as the long. The long also stores integers. Okay, remember, these can only store integers. Int and long can only store integers and not decimals and fractions. Remember that. Okay, there's a separate data type for that. And long can store a value between 2,147,483,647 to minus 2,147,483,647. And that's the number for the long. Okay, that's pretty big, right? I don't think you are going to be needing, oh, that's a typo there. Make this 1 and that's not 2. So this is 1. Okay, so I don't think you're going to be needing bigger numbers than that. So yeah, now let's move on to our next type of data. We saw how to store numbers, but what if you want to store decimal numbers? Let's see how to do that. You need a data type called float. Now this float can store decimal numbers. The problem is that it only has precision to what is that, 6 to 7 decimal digits. Like it has only precision to, maybe you can say, only till this point it's precise, not more. Okay, this is a point, not a comma. Only till this point it's precise, not, it's not precise more than that. Okay, but then yeah, it'll be used, it can store even integers. Using this you can store 8 and stuff. You can store 8.1, you can store anything. But there's a small thing, when there's small difference when you store an integer in an int and a float. Okay, in an int, if you store 8 and you try to print it, right, what the output will be 8. Okay, but in an int you try to store 8 again, any number, okay, and int integer, then it'll become 8.0 when you print it. Now what, why 8.0? Doesn't make sense, right? The thing is that this is oh, not an int, this is a float. 1 minute, let me just convert this to float. Yeah, it'll become 8.0 because the float is designed to handle decimal and not integer values. So it'll become 8.0. This won't affect any calculation if you do with numbers and all the stuff, so don't worry. But that's why I always say to use the correct data type for everything. If you're storing an integer, don't use float, use an int. Okay, that's how to store decimal numbers. Now what if you only have 6 to 7 digits of precision, right? What if you want more precision, like you want to store like so much here? Now the thing is that you have to use a, what is that called, data type called double. This has more precision. You can store like, yeah, you can store that. You can store that number. That's called double. The thing difference is again that it takes a more space than the float. So if you want to store like 3.1, 3.2, don't go for double, go for float and use float. Okay, so that's double. it gives more precision than float. Next, we have the char. Now, what is a char? Okay, now take a moment and look at your keyboard. Now, you will see that leaving all the caps lock, shift, and delete, what's the arrow keys and the F1, F2 escape keys. Leave all that, and then you will see that there are letters. There, oh my god, there are letters. There are numbers, and there are special characters. Okay, these are all comprise of a character. A character basically comprises of one of all the things I listed. Maybe it comprises of a letter, a number, or a special character. Okay, so a character is basically maybe q is a character, w is a character, this is a semicolon is a character, 6 is a character, but PO is not a character because it's supposed to be a single one. It's not supposed to be like multiple. This is not a character. Okay, this is a character. Okay, just a single. What is that? What is that? Letter, number, or special character is known as a character. Okay. So how do you write a character? A character is basically put in between a set of single quotes. So this is a character. A is currently a character. The thing is that this is not equal to this. Okay, so big A and small a have their own differences. Okay, so you should be very precise. It's case sensitive right there. So now we have seen what is a character. It is written between single quotes. This is a character. This is a character. This is a character. Okay. Now moving on, we have something known as strings. Now, for example, you want to store multiple characters. Maybe you want to store a sentence. Now, how do you do that? You have to use something like string. If you come from a C++ background, don't do this. No, don't do this. It is in Arduino. It's S string. Now, this can store multiple characters. A character is written between single quotes, but then a string is written in double quotes. So I'll write my name here. So right now this is currently a string and this is a character. Okay, so you can put any sentence like my name is the Uno guy. Okay, so this is a string. Okay, now if you want to count the number of characters in here, you might say, okay, maybe this is one character, this is the second, third, fourth, fifth, sixth, seven, eight, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18 characters, you might say. But then if we take this, remember this, the double quotes are not included as a character in a string. Okay, so if I copy this, you can use Control C also, but just to show you. And if I put in an online character count tool, you'll see the total of characters is 21. I in the online character count tool, it's saying 21. Like, is it wrong? Like, is the tool wrong? No, it's absolutely correct. Now, the thing is that white spaces, the blank spaces here are counted as characters. So if you add them up, there are two blank spaces. So 19 plus 2, 21. So that is blank spaces are counted as, the what is characters. So that is all the types of data you can have in Arduino. Okay, so now let's move on. Okay, so we have seen the different types of data, right? Now we're going to see something known as variables. Now we have seen how like what are the types of data, but we don't know how to store the data yet. So we have a concept called variables in every programming language. In C++, it might be a bit tougher than Python, but it's fine. Okay, so how to store one? I'll just tell you: data type, variable name. This is the syntax, okay, and then it's value. Okay, so if you want to store an integer variable with maybe say the number 9, what we do is the data type will be int, the variable name. Now this variable name is very important. No special characters are allowed in the variable name except an underscore. The variable name cannot start with a number. It should always start with an underscore or what is that, a letter. Okay, So remember that, but numbers can come everywhere. You can say maybe the variable name is name. You can say variable name is name. You can put name 1 2 3 4. You can do that. Okay, so let's call a variable for now. Let's call it variable. What's wrong? So let's call it variable, and we said the value should be 9, right? So 9, and don't forget to put the semicolon. Now with this, you have declared a variable. Okay, so this is how to store data in a variable. Okay, so int variable equal to 9. Now the variable which you had there is of type int, and it has 9. It has the value of 9 stored in it. Now you've not learned so much programming that you can actually check if it's 9. I'll put that in future videos, but then for now int variable equal to 9. But what if I want to store 8.1? Okay, you can't put an int, right? You have to put a float. So float, let's call it decimal if you want, I guess. Decimal 8.1. Okay, 8.1 is now what? It's a float with the, what is that? Number 8.1. This is how you store. Okay, now we have learned this sketch, right, in the previous video, how to link the onboard LED. So you know the syntax, right? LED built-in can be replaced with a pin number if you're using an external LED. So let's replace it with 13 here. So if I replace it with 13, this doesn't actually look that good. Now we just put 13 everywhere, but then we can do something. On top, you can make a variable known as int. What is that? LED is equal to 13. Now this has the LED has the what is that, value as 13. So even this is 13. So we can just replace it here. So this is more useful than just putting 13 everywhere. It looks more organized as well. So now the sketch will work exactly the same, no differences, but then this is a more neater representation of a blinking LED. Now always remember to store, what is that, to declare your variables on top of the void setup, means before the void loop and the void setup. If you declare it here, you'll get an error. If I just verify, I won't save it. I don't really save like these things, so I'll just click cancel, not saving the file now. LED was not declared in the scope, and yeah, it was not declared. If we put, again, we cut this, put this up here, and then we verify the sketch. Again, don't save. You can see it says done compiling, successfully done. So yeah, that's good. We actually have done it properly, and that is on it for variables. So we can put anything. We can't put this as a float though, because this is actually a pin number. So if I put 13.1, it may not give any error. Let's see if it gives an error. It does not give an error, but then you will not get your desired output. That means on pin number 13, it will not blink. The LED won't blink because it was assigned to 13.1, which is a pin that doesn't even exist. Okay, so yeah, that is variables and data types for this video. I hope you enjoyed this video. If you did, please drop a like and subscribe to our channel so that you can get more awesome content like this. So thank you for watching. Bye bye.